Let's suppose we have a question which goes like, an object is kept at a distance of 30 cm from a concave mirror of focal length 20 cm. We need to find out the position, nature and magnification of the image. Alright, for position and nature, let us take the use of mirror formula. We need to find out V. Alright, in this case, the focal length to be taken is minus 20 cm. Why minus? Because already given in the question that it is a case of concave mirror. For object distance also, we shall be taking it as minus 30 cm. Just like we have already discussed with our sign convention. Alright, let us put the values over here. This becomes minus 1 by 20 minus of minus 1 by 30. If we just solve it, we'll have minus 1 by 20 plus 1 by 30. Take the LCM and solve it. So, our image distance comes out to be minus 60 cm. Since 1 by V equals to minus 1 by 60, that means our image distance is minus 60 cm. Now, look the negative sign over here. Minus means the nature of the image is real. We have our one answer. It will be a real image. Position. Position is 60 cm. The magnitude gives the position of the image. So, image is 60 cm in front of the mirror. So, we have got our position. Now, what about the magnification of the image? We already have U from the question. We got V from the mirror formula. So, our magnification will be minus V by U. Here again, values to be put according to the sign. Minus of minus 60 upon minus 30. So, our magnification comes out to be minus 2. Even from the magnification, negative sign tells that the image is a real image. And 2, if the value is greater than 1, that means our image is enlarged image. Our magnification will be minus 2. Alright, let us discuss another kind of question. Let's suppose we have another set of question where we are given the height of the object. A 2 cm tall object forms a real image at a distance of 50 cm from a mirror of focal length 25 cm. We need to find out the magnification and size of the image. Alright. Just see, in this kind of question, they have not specified the type of mirror. But what we have been given that the image formed is a real image. And we know that the only case where a real image is formed is the case for a concave mirror. So, the focal length so given will be of a concave mirror, which is 25 cm. Height of the object is given 2 cm. The image distance, since it is a real image, so image distance will be minus 50 cm. Let's put these two values in our mirror formula and get the value of object distance. From here, 1 by V minus 1 by 30 plus 1 by U equals to minus 1 by 25. If we just rearrange it, we will have 1 by U equals to take the LCM and you will have the value of your object distance. So, taking the LCM would be 50. This will be 1 minus 2. So, it comes out to be Hence, our object distance is minus 50 centimeter. Now, using this value in our magnification formula, we'll have m equals to minus v by u. So, our magnification would be minus of minus 50 upon minus 50, which will be equal to minus 1. Of course, there should be a minus sign because the image is a real image. Now, let's come to the size of the image. Once we have our magnification, equate it to our original formula hi upon ho. From here, putting the value of height of the object as 2 cm, we'll have height of the image as minus 2 cm. Negative sign tells that the image is an inverted image, and it should be because in the question it is already given that it is a real one. Alright, let us discuss another set of questions. Let's suppose we have another set of questions in which we have been given the magnification and focal length of any mirror, and we need to find out the position of the object. An object forms a 0.5 times magnified image from a convex mirror of focal length 20 cm. Find the object position in front of the mirror. Alright, we have given our focal length as 20 cm. Since it is a case of convex mirror, so focal length would be a positive value. Along with it, we have been given the magnification as 0.5. Now, since it is a case of a convex mirror, the only images formed are virtual image and erect image. So, magnification will again be a positive value. Alright, let's come to our mirror formula equation. From here, take V in terms of F and U. Alright, put this value of V in our magnification formula, which is minus V by U. So it becomes, instead of V, we will be taking the reciprocal, Fu upon U minus F. Solving it, we would get the expression as F upon F minus U. Alright. In the magnification formula, we know the value of magnification, we know the value of f, and we need to find out the position of the object. It could be easily done. Let's do it over here. Magnification equals to focal length upon focal length minus u. Resubstitute the values on left hand side and right hand side. We will have 10 minus 0.5 u equals to 20. From here, u equals to 10 upon minus 0.5, which is nothing but minus 20 centimeter. So from here, we have our object distance, which is minus 20 centimeter. Once we have our object distance, if it had been given in the question, what is the position of the image, then we just need to substitute this value in our original mirror equation, and we would have got the value of our image distance. Alright, these are three sets of questions which are being focused by the board on your mirror formula and magnification, that is your reflection. Let us talk to our third topic, which is refraction.